This is video 15.3. In the last video, we were talking about naming alkanes and kind of the general structures that go along with it. Now we're going to talk about the next homologous series, which are called alkenes. So notice they only change by one letter. It goes from an ane to an ene, and now they're still aliphatics, right? Remember, just long, open chains. That's what that term aliphatic refers to. And then now they're unsaturated, right? So that means there's a double bond or a triple bond somewhere. In this case, alkenes have double bonds, okay? Their general formula is CnH2n. So one thing in the last video I just want to make clear that when you're given a formula, okay, when you're given a formula like C4H10, it's kind of a little guess and check as to, hey, is this an alkane or an alkene or an alkyne? But you have these formulas. They are on, when you look in your reference table, they are on table Q. All right, you have all three series, homologous series, kind of the structural formula is shown to you. The general formula is given to you as well. And it even tells you what N refers to. N is the number of carbon atoms. So if you're given a general formula of something like, oops, I did it again. Something like C4H10, well, there's your N value, so now you can just plug that into your formulas, and let's see, would this be an alkene based on this? Well, okay, if I have C4, if I do 2 times 4, that would give me 8. All right, for this to be an alkene, I would have to have a formula like that with that C4. So this formula right here, again, this is just an example I made up, would not be an alkene because it doesn't satisfy this formula. So yes, there is a little bit of guess and check when you're given a formula trying to identify what series it belongs to, but again, you're given the formulas, so just know where to look for them. All right, so we can ignore this stuff right here. It's just a little bit of an example. Big thing getting back to this, guys, they end in ene. So that's one of the big changes, is they end in ene. N-alkene, the N tells you what carbon number that the double bond is located at within the molecule. Use N only if the molecule has more than 3 C's, okay? I am not doing well today with my pens. Only if there's more than 3 carbons. If there's only 3 carbons, guys, it's always going to be on the first carbon, okay? So we can see prop, right, that prefix 3, so we know it's C3H. Now again, figure it out. So 2 times the N value, all right, equals 6, so it's C3H6, and that's the structure that we have down here. Okay, if you count 1, 2, 3 carbons, then there's 1, 2, 3, 4, 5, 6 hydrogen, so it all measures out. Now notice, guys, we could flip this around. You may think, well, don't we have to label where that double bond is? Not if there's only 3, okay? If there's 3 or less, so 2 or 3 carbons, it's always going to be that first carbon, because if we could switch this double bond over here, okay, it's still on the first carbon because, again, it goes to the lowest number. So you only need to include a number if there's more than one location that could potentially be at. So let's take a look here at this example. So straight chain alkenes, all right, same type of idea with those alkanes. The only thing that's going to change now is, hey, there's a double bond, so we've just got to identify where that is. So start with counting your longest chain. 1, 2, 3, 4, 5. So there's 5 carbons, all right? So if I were to write that formula, it's C5, and then H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're given the pictures, you just have to count them. All right, simple. Don't make it harder than it needs to be. So think to yourself, okay, what's my prefix for 5 carbons? Again, you have table P. Look at table P for the prefixes. All right, so C5 means pent, okay? So it's going to be pentene, but is there more than one possible location for that double bond? Absolutely, because it could be here, it could be here, it could be here, or it could be here. There's 4 different locations. So you've got to count up, okay, label your carbons so that, again, this bond is in the least number of carbon. So this would be 1, 2, 3, 4, 5. So this would be 2 pentene. I'm going to clean that up because it doesn't look good to me. Okay, 2 pentene. That's it. The straight chain alkenes, guys, where you don't have any branches, or straight chain alkanes or alkynes, those are the easy ones. I would anticipate you having something like that. Maybe they'll give you something kind of simple on the regents if they had you kind of name one. Some of the ones I know with the alkanes in the last video were a little challenging, and there may be a couple of them. We need to be aware of them, but I don't anticipate anything super, super complex with it. All right, so try this one on your own. Count up how many carbons you have. 1, 2, 3, 4, 5. So again, this is another pentene, but notice, oh, we have one double bond here and we have one double bond there. Okay, so now we have to think, okay, we got to take both of those into account. So label your carbons. 1, 2, 3, 4, 5. Notice also, guys, just a little aside, carbon has to have 4 bonds, so it cannot have more than 4 lines coming from it. Make sure that when you draw structures that every carbon has 4 lines coming, whether it's a double bond or triple bond, those, right? 1, 2, 3, 4 lines. So we have double bonds at the first carbon and the third carbon. So it's going to be 1, 3, okay? Then we have 1, 2, 3, 4, 5 total carbons. So there's our prefix pent. It's going to be called pentadiene. Okay, since there were 2 double bonds, that's where we get that prefix di. We kind of put it in the middle between the prefix of the number of carbons and then the suffix of ene. All right, so that would become pentadiene. Pentadiene. Okay. Now, branched alkenes. So where it gets a little more challenging, right? Just like with the alkanes. The branch prefix comes first in the name. The parent chain comes last, just like we did with alkanes. Okay, along with the number of where the double bond is located. One thing you want to remember, though, guys, is the double bond, all right, is going to dictate the number system. Okay, so here, if we count out our longest chain, right, I could go 1, 2, 3, 4. Okay, or I could go 1, 2, 3, 4. So it's going to be 4 either way. But look at where the double bond is. Right, that's going to dictate it. So we got to go through here first. That's going to be my longest chain, or this. These are the same thing. And then a couple videos we're going to talk about things that have the same number of atoms but have different structures. Either way, it's the same thing. Okay, this is still 1 carbon, 2, 3, 4, or if I wanted to call this guy down here 4, it's the same either way. There's still something coming off of that third carbon. All right, so let's see what our branches look like. I got a branch here and I've got a branch here. Start with the numbers first of where the branches occur. So I've got it 2, 3. Now, what are these branches? Think back, guys. Branches get the suffix "il." So this is 1 carbon and 1 carbon, so they're both going to have the same prefix. So it's 2, 3, dimethyl. Why is there a di there? Why do I need it? Because there's 2 of the same groups. If they weren't the same group, then we wouldn't use the prefix di. We would say, hey, ethyl and methyl or whatever. Okay, but this is 2, 3 dimethyl. Now I'm going to name my long chain. So there's 4 carbons in my long chain. So that's but is the prefix tene. Okay, but I forgot something before I even do that. 2, 3 dimethyl, 1 butene. Again, we have to put that number in, guys, where that double bond is. Otherwise, that could have been in 3 different locations. So make sure you include that. Again, I know this isn't easy. They throw this at you, but again, you have a lot of resources in your reference table. Table P and Table Q are going to be your best friends for this. Okay? So that's it for alkenes. Very similar to alkanes, guys. Same process, except the end now gets the ene suffix, and then we have to make sure we tell the number as to where the double bond is. So until the next video, I'll see you later.